Hey, this is for 33 and 633 construction planning and scheduling. In this video, you're gonna learn about schedule updating, which is the first lessons of this module 5. Okay, so here are the two learning objectives of this lesson. First, you need to explain the schedule updating process, and second, you need to update the PDM and Gantt chart schedules given some changes on the activities. Okay, so first of all, let's learn a few key concepts about this topic. So first, let's recall the project schedule definition. What is the project schedule? So it is basically a written document of the plan on how to build the project. So this plan is basically a initial plan, and it can change during the project construction stage, because once the project conditions change, for example, the weather's conditions, the resource availability changes. So your project schedule will be basically changed as well. Okay, so why do we need to develop a updated schedule? So a updated schedule, because it can show the effects of any changes or delays on the project schedule and costs. So let's say for some reason you have to delay the start of a particular activity. Uh, let's say if this activity is on critical path, so this delay will extend the project duration for sure. So with the updated schedule, you can propagate the change and identify the impact of a particular change on the whole project duration. And also, once you integrate all the changes, all the events occur during the construction stage into the schedule, and you document the causes of those changes. By reviewing the updated schedule, the project manager team can determine who should be responsible for a delay on the project. And sometimes we can calculate or allocate the responsibility portion to each different team members. Okay, so to correctly update the project, what you have to do is to closely monitor the project. So monitoring a project consists of reporting the events that have occurred on the project in a particular period of time, as well as all the work items that you complete in that period of time. So examples of events could be like the adverse weather event. It's raining too much. So that is kind of like event that you want to document and add into the schedule. Or is any delay in design approval? So let's say the owner, they have some delay in approving their design drawings. So without the design drawing approved, you cannot start doing the construction work. So that's kind of event you need to document and add it into the updated schedule. All right, so how do you monitor a project? So there are different methods here. So for small projects, for small projects, we can do like direct observation by making few visits. You go to the field and do observations and do some measurements to see what items completed, and just being at the field you can know, okay, what events happens um, on the projects. For larger projects, typically we use like photography and video tabs. um, so with this you install a few videos cameras surround the construction site, and do video tab, or like periodically taking pictures So, and then this kind of data will be given to a team of many people, and they will watch and look at the pictures and identify the events and all the work items completed during a particular day. All right, and sometimes we use checklists along with these two methods to basically to support the monitoring process. So let's say you observe that on the field, you observe that, okay, so this activity is done, so you can just put a check mark there to indicate that this activity is done. So it's just a efficient tool that you can use to improve the efficiency in your monitoring process. Right, so this table shows you different types of information that you need to update on the schedule, as well as a common list of courses that typically cause changes on the project schedule. So on the left column here, this is the information that we need to update. So you need to change the start day, duration, finish day, logic, and the list of activities. So let's say you delay the start of a particular activity, so that's what you need to update on the updated schedule. And sometimes the activity duration is getting longer, so you need to update the duration on the updated schedule as well. And finish day, obviously. And then sometimes logics, let's say you originally plan that A has to be followed by B, but once you're doing the construction work and you found that this logic is redundant, it doesn't have, B doesn't have to follow A, so you can remove that logic in the updated schedule. And also sometimes you need to remove or add additional activities into the schedule. So that happens, especially when, let's say, the owner asks you to do further work, additional work. So with that case, you have to add that activities into the schedule. All right, and the second column shows you a list of courses of updates. So why do we need to make updates? So here are some potential courses. Weather, adverse weathers. When the weather gets worse, I mean, the production rate would be changing, or you need to delay the start so that I mean, let's say some activities you cannot start during the rainy time, so you have to wait until the rain is completed. So that will impact the start date of some activities. Or resource availability, you cannot start doing the work without materials or without workers, so it may impact the start date. And let's say your resource level is not optimal, so the production rate would be less than what you estimated, so the duration is going to be longer. So that may require update on the project activities duration and start. And then change orders, as I said, like sometimes the owner asks you to do additional work other than what specified in the contract. So with that, more activities need to be done. So you need to add activities into the schedule. And then another cause of updates is that the productivity, the actual productivity is actually lower than what you estimated. So when you estimate the production rate, again, you use historical data, you use your experience, but it doesn't mean that is going to be the actual production rate on the field. So sometimes the actual production rate is lower than estimated. So that means the activity is going to be taking longer to be completed. So you need to update the duration of the activity. And then material delay is another common causes of updates. Many times the material is being delayed, so you cannot start doing the work without materials. So you have to delay the start of some activities. And then changing equipment or may also need to may also require you to change the schedule. let's say you use a better equipment, so production rate would increase. Once the production rate increases, you have a shorter duration for some activities, and you have to update their durations, and then logic or correct the logics on the schedule. So in the original plan, as I said, in the original plan, you plan that A has to be followed by B, but it's not correct. Once you go to the view and you see that this constraint is not necessary, so you have to remove the constraint. So errors when you estimate the schedule, error when you plan in the schedule is another source of schedule updates. Okay, so how do you develop a update schedule? Two steps. Step number one, create a baseline schedule using the agreed as planned schedule. So the agreed as planned schedule is the one that you submit to the owner before you start doing construction work, and this schedule has to be approved by the owner. And once it is approved by the owner, you can use it as a baseline. So if any changes on the schedule, we need to compare the update schedule with the baseline schedule to see how much change on the project and who should be responsible for the changes. And then number two, you make changes using the actual data on the construction field and update those information on the baseline schedule. That's when you changing start date, finish date, duration of the activities, or adding new activities into the baseline schedule to get an updated schedule. And there's some important notes here. The schedule should be updated regularly, weekly or monthly, and then sometimes you also need to update the project based on, additional requirements from the owner. Sometimes in addition to weekly and monthly report, they want you to make a report on the progress of the project for a particular period of time. So you may have to develop additional updates on that because of those specific requirements. And then the update schedule at the completion, that means when you complete the project, when the construction work is done, the updated schedule is gonna be called as built schedule. So this is the final updated schedule that you develop for the project, and it's showing what is constructed and what happened during the construction phase. All right, so this diagram showing a typical routine for updating schedule done by the personnel at Florida's Department of Transportation. So they develop monthly schedule updates, and they usually start on the first Thursday of the month. So from this day, they start documenting all the events and work items completed on the projects, and they finish updating the projects on the last Friday of the month. So in the period of 1 month, they monitor the projects, identify all the events, and then documents all the events and add those events into the schedule. All right, next step, after they added all the events and the status of the activities to the baseline schedule, now they recalculate the schedule on Primavera. So you can use MS Project if that is the software that your company is using. So at this stage, you basically recalculate the schedule using the software, so that you can calculate the start date, finish date for the uncompleted work. So here you calculate the incompleted work. Or the remaining work, right? And then you also calculate the new duration of the project because of those changes in that month. All right, so after you run the project calculation, now you need to check any issues. Let's say after running the schedule calculation, you found that okay, this project is gonna be delayed for 10 days. So this is a big issue. I mean, you don't want to delay the project by any days. So this is the issue, and next day they need to talk with the project manager to solve the issue here. So the project managers will identify responsible persons to resolve any issues. So let's say if the project manager they don't want to delay the project, they want what I have to do. So the one solution is that they can do like more shifts instead of one shift per day. They do 2 shifts per day, or they can hire more workers, increase the resources, so that they can accelerate the project for the remaining portion of the project, so that they can catch up with the project deadline. So that is what the project manager has to do. And once the result is solved, you got a new schedule, right? So basically you're changing the plan on the remaining activities. You're changing the logic, you're changing the production rate, you're changing the duration of the remaining activities so that you can solve all the issues. So once the issues solved, that means you got a new schedule. So you got a new schedule, and this new schedule will be propagated into the system and share with everyone else in the project, and this new schedule will be used as again as a baseline, and this baseline will be published and shared to all the project members, and that is the start of the new cycle. So you use that new project schedule as the baseline and for the next cycle. All right, so this is another examples of like S-plan and S-build schedule. So in this schedule, you see the top is the S-plan schedule, and the bottom is the S-build schedule. So by looking at these two schedules, you can quickly say that okay, this project is delayed for 70 days. This is the completion date originally, and this is the new completion date. So the project was delayed. All right, so the question is why this project was delayed? Why was it delayed? What are the causes for this delay? So now you need to look at the SB schedule, identify the events on this SB schedule. So looking at this, you can see that okay, activity 1, 2, 3, 4, 5, and the SB schedule, you also have 5 activities 1, 2, 3, 4, 5. So the number of activities does not change, but you see there's some events here like the hurricane preparation activity and then hurricane evacuation activity. So that means that okay, during the course of this project there was a hurricane occur sometime in April, in August and September of 2017. So this event may have an impact on the project. So let's see how does this event impact the project. All right, so this event, the hurricane occurred during this period of time. So this is exactly the same time when you do activity 2, right? So in the middle of activity 2, the hurricane occurred. So it looks like this event impacts the activity number 2. All right, so is that true? So now you look at the SB schedule and you compare the SB schedule and S-plan schedule for activity 2, and you say, as you can see here, so activity 2 start as planned and then finish sorry, so finish pretty much as planned. So mostly no change on activity 2, just start and finish as planned. So you can say that already this hurricane event does not make any impact on activity 2. So which activities were impacted by the hurricane? So now let's go to another activity, activity 3. So you can see here activity 3, the finish date has been pushed back a little bit. So right here, it's supposed to be finished in April, but actually this activity finished on May. So it was pushed back 1 month. So what is the reason behind this delay? Is it because of the hurricane? Looks like yes. So during the period when you perform activity 3, so you need to do some other activities like hurricane recovery. So this activity happens in several months, and this overlap. So this overlap with the time when you do activity 3. So looks like this is the reason why activity 3 is delayed. All right. So, but as you can see here, activity 3 delays for just about a month. But the total project duration is about 3 months or so. So what other causes of the project delay in this particular example? So you got 5 activities, like 1, 2, 3. So and the problem should be in the remaining 2 activities, 4 and 5. So now you look at activity 4 and 5. You just measure and compare the length between these 2 activities. You just compare the length of these 2 activities with the original plan. So you can see here on both activities, the length of those two activities are extended. So that means it took activity 4 and 5 more time to be completed. So the delays on activity 4 and delays on activity 5 basically extend the whole project duration. All right. So now let's say what are the reasons why activity 4 and 5 was delayed? How do we know? The answer is we cannot know the reason why, but we can guess. So there are potential reasons why activity 4 and 5 get extended. It could be because the original production rate is much lower than the actual. So based on the original plan, you got this estimate based on your guess on the production rate, but actually production rate is much slower. So that's why it take you more time to complete 4 and 5. So could be the errors in estimating production rate, right? Or any other reasons. I think that is potential reason why activity 4 and 5 took more time to be completed compared to the S plan. All right, so now let's do one examples on schedule updating. So in these examples, what you have to do is to update the schedule for this so this original plan, and at the end of day 18, you got a lot of information from the superintendent. So this superintendent gives you the actual information about what happened on the field. So what you need to do is to update or recalculate the PDM network as of the end of day 18 using the actual information from the field. All right, so what you have to do, you need to look at the information and do some interpretation here. So activity C will start in 3 days. So what does that mean? So from here you know that, okay, the early start of C has to be 18, which is the day that you evaluate the project, the current date. And it says activity C will start in 3 days. So that means activity C will start on day 21, right? And then activity F has been progressed for 5 days. So that means, so when did activity F start? So early start of F is gonna be 18 minus 5 or 13, right? So today is 18 and activity F is already progressed for 5 days, so that means it started on day 13. And you got another information. So this activity take additional 3 days more than the time originally allotted. So now you can calculate the new duration of F. So new duration of F is gonna be the old duration plus 3 days. So looking at the as planned schedule, what is the old duration of F? It's 21. So that means the new duration of F is gonna be 21 plus 3, so you got 24 days. All right, another information about activity I. Because of the delivery problems, so activity I has to be delayed by 10 days. So you got the early start of I is gonna be 10. No, it's gonna be equal the old or the original start date, which is 47. So 47 47 plus 10, so you got 57. Next, activity G must start at the same time as activity I begins. So this is kind of a new constraint. So you got G, no, you got the relation from I to G, and this is the S relationship. And also G cannot complete it until 2 days after I is completed. So that means you got another constraints, I to G through the FF relationship with 2 days lag time. So these two are the new constraints for the projects. And then another information, activity E is on schedule, so that means no change on start and finish of activity E. Alright, so based on those information from the field, next we need to recalculate the network to know, okay, the new project duration, new start date, and finish date for the remaining activity. Okay, so now let's calculate the network to calculate the new duration of the project. So again, the current date 18. So this is the day that you evaluate the project after getting all the actual information from the field. So from this information, um, we got information about C, we got information about F. So F is already started. So F is already started, and it start on date uh, 13. And then E, it is on schedule. That means the starting and finish should be similar to the original plan. So it's 16 and then finish on day 33. And let's go back to the activity F. So F start on 13 duration. New duration is um, 24. So that means F we finish on day 37. Okay, so a question. How about A and B? Um, are they completed already, or are they not yet completed? So based on the information, we don't see any update on the logic between A, B, and B, F. So that means no change on those logics. So based on those logic, that means those activity A and B already completed. Is already completed because the current day is 18 and F is already started, E is already started, so that means the finish of B is already gone. So it should be before 18. So A and B has to be completed. So all right, next let's do activity C. So activity C will start in 3 days, and based on that we got the new start of activity C, which is 21. And no information about the duration of C, so the duration has to be the same as the original. So you got 18, and from that you got the finish of 39. All right, next activity I. The new start is 57, and no change on the duration, so it has to be 6, and then the finish of I needs to be 63. And what next? Activity G. Okay, so we got new constraints between I and G. So you got S relationship from I to G, so you need to add a new constraint here from I to G, and from start of I to start of G, and then you got another additional constraints is going from finish of I to finish of G with the with 2-day lag time. So you have to add those two new links into the network. All right, next activity E, it is on schedule, so we already add it into the schedule. So that is it. That's all the information we got from the field. Next, now we need to recalculate the network to identify start and finish for the remaining activities that we don't know their start and finish yet. All right, so to calculate this network, what you have to do just to go forward pass. So activity I, you go from E to D, you got 33, and F to D, you got 37. So start of D has to be 37. You take a larger one, And then duration of D, no change, no information about the changes on duration of D, so it has to be the same as the original plan, which is 8. So you finish D on 45. How about activity H? H, you go from F, you got 37, go from C, you got 39, so you take larger one, 39. And then activity H, duration 10, so you got 49 as the finish. Activity J, you go from H to J, you got 49, and the duration of J has to be 9, and then you got the finish 58. How about activity G? G, if you go from D, you got 45. If you go from I, you got 57. So start of G has to be 57. In finish of G, if you add start by duration, you got okay, hold on. Activity G, duration is 11. So you add if you add start by duration, you got 68. But the finish of G is also constrained by the finish of I. So if you go from finish I to finish G, you got 55. So between 68 and 65, you have to take the larger one. So this has to be 68. Alright, so K has 3 predecessors. You go from G, you got 68. You go from I, you got 53. You go from J, you got 58. So this has to be 68. And then duration of K4. So new duration of the project is gonna be 72. So this is the forward pass. Next, to calculate late start and late finish, now you need to do backward pass. So I'm gonna do that quick. 72 and then 68. Activity J, 72. I'm sorry. 68 and then 59. All right, next activity I. You go from K, you go backward from K to I. You got here has to be 68, and then start has to be 62. No, I'm sorry. I made a mistake here. We cannot do I until we know activity G. So just leave it there. All right, we have to do G first. So if you go from K to G, you got here 68, and then start 57. All right, now we can do I. If you go from K, you got 68. If you go from G, you got 66. So take smaller one, 66. And then start. If you go from G, you got 57. If you minus the finish by duration, you got 60. So you have to take smaller one, which is 57. Okay, next. Now you can do activity H. If you go from I, you got 57. If you go from J, you got 59. So take smaller one, 57. And then minus 10, you got 47. Go to activity D. D has 2 successors. So if you go from G, you got 57. If you go from I, you got 57. So they are the same. Take 57, and then minus 8, you got 49. Right now you can calculate F, F 47. All right. Question: do we need to calculate the late start of F? The answer is no, because F is already started, so you don't have to calculate late start. And then next activity E. If you go from D to E, you got 49. And then same thing here, activity E is already started, so you don't have to calculate late start of E. All right, and the last activity C, go backward from H to C, you got 47, and then start 29. All right, so this is the excuse me. So this is the whole updated schedule. So you got new duration. So the total delay is gonna be 72 minus 60. So you got 12 days delays. And you got the new start and finish days for many activities in the network. So you can separate the network into two different parts like this. So this is the completed work, because your current day is 18. So A, B is already completed. E is already started. F is already started. So E and F are partially completed, and activity C is not started yet. So everything on the left of this line is completed, and everything on the right side is incompleted. So based on this schedule, you can quickly identify the remaining work and the completed work, and their new start and new finish. All right, so that is the one example about how to update the project network. All right, so you can you can use the update network schedule to develop bar chart. So what you have to do is just looking at the VM network and then convert it into the bar chart schedule. So in this schedule, I use the black line to indicate the baseline schedule, and then green line, blue line to indicate the updated schedule. So from here you can see visually how the activities has to be moved because of what happened in the past. So you can see here, like A, B, no change. Activity C has to be pushed back a little bit. Activity G has to be delayed for a lot of days. And then activity I, the same. You have to push activity I for many days. All right, so this is a kind of like bar chart that's showing both original baseline schedule and the update schedule. All right, so a few things that you need to keep in mind. So what if you are just simply behind schedule? Let's say after updating schedule and you found that you are behind schedule. So what should you do? So first of all, you need to is plan, I mean, how far behind you are. I mean, how many days you are behind schedule, and what you need to do is plan what the major causes of the delay, and you need to think of a way that you can get the project back on schedule. So as I mentioned in the previous examples, you may have to like accelerate the project by hiring more workers. I mean, also doing more shifts per day instead of one. You do 2 shifts per day, and with that you can improve the production rate, and you can shorten the project duration, and you can avoid project delay. All right, so there are different ways that you can have to get the project on schedule. Ask the worker to do overtime, ask the worker to work on Saturdays, Sundays. You can work multiple shifts, or adding resources, use more powerful equipment. Sometimes you may have to change the logics on the schedule. So with that, you can have to reduce the project duration and avoid project delay. All right, so there are 2 assignments. First, the homework file, which is manually scheduling, updating schedule, and then homework MS project. So look at the tutorials number 2 and follow the instruction there. So I'm not gonna to teach you how to use MS project. So this you have to do it by your own. All right. Check the due and points of those assignments on Canvas. All right. I'll see you in the class.